Hello class. In this video, which is solving absolute value equations, part 1, I'll be showing you how to solve absolute value equations with a variable on one side of the equality. We are looking for two solutions in every single problem. Sometimes we'll have one or no solutions when we get down to it though. So we're just taking a look at the definition of absolute value here. The definition of absolute value is the distance away from zero. So the absolute value is defined as the distance away from zero. So if I want to solve these three equations, let's take them and take a look at the distance away from zero. What value of x gives us a distance of 5 away from zero? Well, if you take a look at the value 5 is 5 away from zero, but the value of negative 5 is also 5 away from zero. So this actually has two solutions, x equals 5 and negative 5. Well, how about the absolute value of x equals 0? Well, 0 is right here. 0 is 0 away from 0, so it has one solution. X equals 0 is 0 away from 0. How about x equals negative 8? Well, if the absolute value is defined as the distance away from 0, how can anything be negative 8 away from 0? Well, the answer is no, it can't. So we have ourselves no solution here. So we have an example of two solutions, one solution, and no solutions. All right, let's take a look at the procedure for solving an absolute value equation. Step one is called isolate the bars. What we want is the absolute value equal to some number. We do not have that going on here. So in this particular problem, we have to isolate the bars. I'm going to do two steps here. I'm going to get rid of the 3 and I'm going to get rid of the 2. To get rid of the 3, it's being added, so I subtract it from both sides. Minus 3 from both sides. 2 x minus 1 comes down equal to 6. 9 minus 3 is 6. Now I'm going to isolate the bars a little bit further here by dividing both sides by 2. Divide by 2. And x plus 1 still in the bars, or actually x minus 1. X minus 1 still in the bars comes down equal to 3. Now I'm ready for step 2. Step 2 is called the split. Split the problem into two equations. We need the absolute value equal to the positive version of the number and the absolute value equal to the negative value of the number. So I'm going to do this in black here. We're going to split this equation into a positive and a negative case. We have x minus 1 without the bars anymore. X minus 1 comes down equal to positive 3. and x minus 1 comes down equal to negative 3. All right, so we split it up into two cases where we're on one side of the 0 and on the other side of 0. Now we solve. So the next step is to solve both equations. All right, so this is pretty easy. I just add 1 to both sides and x equals 4. Here I add 1 to both sides, but I'm going to get a different number because I had negative 3 over here instead of 3. So negative 3 plus 1 is 2, negative. So I have two solutions. Both of them fit this absolute value inequality or equality. Last step is to graph if it asks you to. So I'm going to make a number line here. And on my number line, I'm going to put 0 in the middle. 1, 2, 3, 4, 5. I have 4 as a solution. Negative 1, negative 2, negative 3, negative 4, negative 5. And I have negative 2 as a solution. So there's my graph. All right, now we just have a couple more examples. In this example, step 1 is already done. You are going to have problems where step 1 is already done. The bars are already isolated. So step 2 is to do the split into a positive case and a negative case. So I have 15 minus 3x equals positive 6, and 15 minus 3x equals negative 6. Now both these solving is going to give me two different answers. Here I subtract 15 from both sides, and negative 3x equals negative 9. Then I divide by negative 3, and x equals negative 3. Here I subtract 15x from both sides, but negative 3x comes down equal to negative 21, because negative 6 minus 15 is negative 21. Then when I divide by negative 3 this time, I'm going to get positive 7. So I have two different answers here. And at this point, I'm just going to graph it. Both answers are correct. So I have 1, 2, 3, 4, 5, 6, 7. Oh, by the way, this is positive 3 because negative 9 divided by negative 3 is positive 3. Sorry about that. So 1, 2, 3, and 4, 5, 6, 7. Okay, and my two solutions graphed. All right, now we're going to solve this one. Step 1 is not done for us. I'm going to do that in blue. In step 1, I have to subtract 4 from both sides. So negative 2, still with the bars, x plus 9 equals negative 9. Then I divide by negative 2. So x plus 9, still in the bars, equals 4.5. Or you could write it as 9 halves. At this point, step 3 is going to be split, or step 2, sorry, is going to be split. So I split into positive and negative. X plus 9 equals 4.5 positive, and x plus 9 equals negative 4.5. Let's see what this gets us when we solve. So x comes down. If we subtract 9 from both sides, I would guess it's negative 4.5 minus 9 is negative 4.5. And minus 9 from both sides, x comes down equal to negative 13.5. So can we have decimals? Sure. And at this point, I could graph it like I showed you before, or another way of writing this is to write the set negative 13.5 comma negative 4.5. Does it matter which order they go in? No, I just put them from least to greatest. All right, last one. In this last example, I have an absolute value equal to a negative. This should set off alarm bells right here, because an absolute value can never be equal to a negative. So no matter what I put in for x, I'm never really going to get a negative number. So no number or numbers will ever make this true. So without going on and without solving it, I would actually say that there's no solution. So let's back up a little bit. No matter what value I put in for x, I'm never going to get, if I crank it out here, I'm always going to be taking the absolute value of it. So it's always going to turn it into a positive. In other words, I'm never going to have a negative number, let alone a negative 2. So that's why I have no solution. And all you have to do is memorize the fact that whenever it's equal to a negative, there's no solution. You don't have to do any work. And that concludes part 1 video.